Hello there, welcome to a new video of machine learning. Let me make it my screen big, and today we are going to see something about parametric and non-parametric machine learning. This is the series of videos in machine learning. Let's see what is this part is. Before I move on to this parametric and non-parametric, you need to know about what is independent and dependent variable. In statistics, the most often used word is variable. What do you mean by variable? Variable is nothing but your feature in ML and attributes in DBMS or variable in statistics, correct? And it has got similar values and which may vary from one entity to other entity, correct? It's like a different thing. Like if a student has a value, that value may be differ. For a customer, that value may be differ. Similar way we have in mathematics, we call it as variable. The two most common variable are independent, dependent and independent variable. You see there is a independent variable which has an effect which change the effect on dependent variable. So the variable is said to be independent whose influence other variable, who can influence other variable, like A changes B. For an example, if you study 5 hours, you will get, if you study 3 hours, you will get 60% of marks. If you study 4 hours, you will get 70% of marks. If you study 5 hours, you will get 80% of marks. What is this one? This affect your result, this affect your result, this affect your result. This becomes independent, this becomes dependent, correct? If you less, there is always next time, so you will be failed and you have to write that one. The difference which I have given in a tabular form, then there is an example. Definition: variable that is not dependent is called independent variable. The variable that is dependent is called dependent variable. So the variable which is not dependent we call as a independent variable, and this one, and it has a control. 3 hours control, expose, manipulation, all this comes up. 3 hours 60%, 4 hours 70%, 5 hours 80%, dependent and all those things. Whereas this one, outcome, explanation, a response, correct? It is control and it is controlled. It is control and this is control, already done it. Okay, explain the cause and effect of the variable and explain the cause and effect of the variable. This is the independent variable explain. Then example which is given as a, we have got X. What do you mean by X? It is independent variable are represented on X, correct? And dependent variable are represented on Y. So dependent variable, as the age increases, the height also increases. So this age, if it is 2 years, the height will be 2. If it has 4, the height will be 3, somewhere down. If it is 2.5, the height will be. So as X increases, the value of Y will be affected. So it is used to it is used for conclusion. It is used for information, how it got to it. Explain that. It is used for conclusion, whereas information, dependent variable, explain all those things. Experimental proof and everything should be there. So the example which is given here is that we have got age at x-axis and height in feet on y-axis. If the age increases, the height also increases. The other example which I go up is that I'll take it x, the number of hours you have studies, and the pass percentage. If you study 1 hour, I'll give you 50%. If you study 60%, I'll give 6 hours, I'll give you 60%. So this increases. So as the number of increases, the percentage also increases. So this is Y and this is X. So always do remember the independent and dependent variable. Independent variable represented on X and dependent variable are represented on Y. This is the definition of independent and dependent variable. Now let's move on to parametric and non-parametric. Before move on to parametric and non-parametric, we have to know the concept of dependent and independent variable. Now parametric and non-parametric. A machine learning can be summarized with the function f of x, which has input variable x and which has output variable y. So y as your input variable, X is your output variable. This is nothing but your machine learning algorithm. So y is equal to f of x. This is your output, this is your input, this is f, this is machine learning. The algorithm mapping, this mapping function is nothing but your algorithm or from training data. The form of function we don't know, it is unknown. The job of machine learning is to learn from different values. What are the, and see the best fit, learn from practice and evaluate, set a better example of it, which is the best to suit it. Different type of algorithms are used. Y is equal to fx plus c. This is your function. How do you define the best? We use different algorithm which is best fit and tell this is the best algorithm, we use it. So the concept of machine learning is y is your input, x is your output, f is a function. Y is an input, x is an output, f is a function. What is the function? Based on our training data, based on our best output, we say this is the machine learning, which you are example. Now this algorithm is divided into two forms, that is nothing but parametric and non-parametric. Before I move on to parametric and non-parametric, I'll just give you an example. Suppose a friend of mine who's traveling from Delhi to Bangalore. Correct? One, I take an example of 1 and 2 friends. Okay. Now, sorry, please. So 1 and 2. What is this? So before I move on, so this is Delhi and Bangalore. So what is this? Now first example, the friend has updated me that he is going to come down from Delhi to Hungary from so and so flight and everything. So I know from which flight he is going, I know the input, and when he is going to come down, output, by which flight it is going to come down, and what is his luggage, what time it is going to come down. So based on this information, I can able to predict that he is going to come down so and so time, so and so leaving. Whereas the other scenario, my friend is coming to Delhi to Bangalore, but I don't know which flight, which date, which time, and other things. I don't know anything. So I don't know the input, I don't know the output. I only know that he is coming from output. So I don't have any fixed number of it. So the function model has a fixed number of parameters. The function value will have a fixed number of parameters, whereas the function value don't have a parameter, because I don't know from which flight is going to come down, what is your input, was it the output. Generally parameter constant have a variable term function parameter that summarize data collection. Parametric, in simple term, anybody can able to map it. So I have all the information available, whereas when constructing a function, the map of input output is not known. The model never know the assumption forms. The function is not estimated. Non-parametric function can learn from any function and map the output. That is concept of non-parametric. We no assumption. So what we have got less data here. Here got more data, as we don't have anything else. More complexity, because we don't have any input. Less complexity, we know what is the input, what is the output. Too many things we have to consider. When is the flight is going, what time is date, what is the date. Here no too many data. What is this example? Linear regression, Navy based, logistic regression, neural network, decision tree, SVM, KNN, etc. The concept, you make it clear. I'll tell you example again. The friend is coming from Delhi to Bangalore. First scenario and second scenario. I know when he is going to, let's suppose he is coming tomorrow with so and so morning flight. So tomorrow with morning flight, 8 o'clock, and reaching by 10 o'clock and book. So based on this one, I've got the input, when he is going to come down tomorrow and everything. So I've got the fixed number of parameters. Whereas the second scenario, he is coming tomorrow. Yes, but we don't know which flight. We don't know what is the time. Nothing. There is no fixed parameters are available to. This is the concept of parametric and non-parametric. Now coming to other one, let's move on to this one. I have just done in a tabular format. What is this tabular format? Definition. Assumption specific form of function map input output. We do not have any fixed format of input and output. We don't have any input and output. We have input and output, so we have mapped. We have got input and output. We have mapped out on this one. Correct. Fixed number. Yes, it is a fixed number. Variable can increase with the amount of data. Yes, there is a fixed number. What all this parameter? There is no fixed numbers. Correct. Let's flexibility restriction. Let's flexibility. I've already got the numbers. High flexibility. I don't have. More efficient in computing. Yes, as we know the data, we can. Less efficient, more efficient require. High risk. Underfitting is more because we have less data. We have got less data, we have got underfitting. In order to know what do you mean by underfitting, I have just given you the link in my video. Please look into that one. I've already explained. Here high risk because overfitting is already available, especially with the limited model learn. Correct. Fast to train and predict. Yes, it is fast because we have limited data. We can able to can model complex pattern. Yes, more over simple data. Overfitting is very small data sets, and these are the things. What are the advantages? Risk overfitting, underfitting, efficiency, more efficiency, flexibility, less flexibility, more flexibility, number of parameter fixed, more advantage. Fast to train, can model anything. Disadvantage, many oversimple complex data. Overfitting with small data. Disadvantages: overfitting with a small data, computational intensity, harder to interrupt. These are the points. Whereas limited cohesion model will available to you. These are the parameters of the one simple important thing is that parametric is that we know the input, we know the output, we can able to predict it. Non-parametric, we don't have anything. In order to know the parametric and non-parametric, we must understand the concept of independent and dependent variable. I hope you have already got this video. Thank you very much.